what I'd like to do is give an overview of the NEON project, its goals, a little bit of the tangible on-the-ground plans for observations. I should say on the ground and in the air plans for observations. And then as more of the sort of less programmatic and more sciencey part of the talk, explain a little bit how we propose to build a continental observatory from a network of sites. I want to back up and talk about where the ecological observatory fits in thinking about the entire Earth as a system. This is the sort of classic Bretherton diagram. It's from 1988, but it's still mostly right. And it indicates how atmospheric and oceanic activities are coupled to human activities and modulated by interactions through soil, vegetation, the water cycle, the carbon cycle, and so on. And that's the context we think of the observations that we make in the NEON Observatory. So very, at a very high level of abstraction, this is an observatory that focuses on the interaction between terrestrial energy and moisture, the physical drivers from the climate system, and terrestrial ecosystems and biodiversity, with a major component of soil measurements and water cycle and aquatic ecosystem measurements. So it, in some sense, is coordinated or interactive with observing systems that focus on the oceans, on the lithosphere, and I'm not sure you would call them observing systems, but monitoring of human activities like through the Bureau of the Census and the IRS. It's interesting to think of the IRS as a kind of an observing system. The ground-based part of NEON, to be very tangible, is a network of about 62 discrete locations where we'll be making a large suite of measurements. Those locations span the United States from the North Slope of Alaska to Hawaii and Puerto Rico, with many, many stops in between. The sites were selected by essentially partitioning the ecological and climatic variability of the continent into a series of regions that are more homogeneous within than they are between. And these regions look like many other regionalizations of the country. You can see here that we're in what we call Domain 17, the Pacific Southwest, adjacent to the Desert Southwest, the Great Basin, and the Pacific Northwest. And so these correspond to an intuitive sense of some degree of commonality in the biota and climate, soils, and topography. And as an observatory, one of the things that I want to do just from the beginning is to emphasize that this is an end-to-end observatory. It's not just a system that collects primary data, but in fact it's modeled somewhat on the NASA model for processing of land surface remote sensing, in that we begin with what we call low-level data, the primary observations that we make on the ground, in the air, and so on and so forth. But we focus on supplying to users relatively analyzed and processed information. And the reason for that is that NEON is intended to look at the connections between the components of the Earth system, between climate, human activities, the lithosphere, and so on. And we want the information to be accessible not only to specialists, but to scientists and citizens who are looking for interdisciplinary connections. So if we were only to provide data like wind and CO2 concentration that require deep specialized expertise, complex software to interpret, then really the only people who would be able to use that information are the people who already have access to it. And so if someone were interested in the relationship between, say, the water flux or the carbon flux and some aspect of say, biological diversity, the observatory wouldn't help them out a great deal. They'd have to become they'd have to gain multiple specializations. So within the information system of the observatory, we're going to produce relatively usable information that would be accessible for interdisciplinary research, for education, and in many cases for decision support.